Hello everyone, good morning. This is Mr. DHAKSHUNHAAMOORTHY, Assistant Professor, Department of Artificial Intelligence and Machine Learning. I am handling subject 22 CS 302, Computer Organization and Architecture for the class second year, 4th semester. Today's topic is data path and control path. Here data path classification shown elaborately in this slide. Here data path and control operations, control units role we can see one by one. Data path components for fetching instruction or R-type instruction, memory oriented instruction and branching instruction. There are three types of instructions. R-type means when we are doing addition operation with the help of registers, add R1, R2, R3. In such cases, R-type instructions. Suppose we are doing memory relevant like loading LW and SW instructions, then data path components for memory oriented instructions. Suppose we want to perform some branching instructions like BEQ, BNEQ and jump instructions like branching instructions, then data path for branching instructions. There are three types of branching instructions. Branching path will be established during the types of these instructions. Control unit, we want to do some control operation with the ALU controls, write control, signal controls and MUX control. So here MUX is playing a major role. Whenever the different types of instructions is executed from R-type instruction into branch instruction, we have to change the data path by using MUX. So arithmetic logic unit performing on particular R-type instruction, from shifting from R-type instruction to memory instruction, we have to change the path by using MUX only, multiplexers. Here the basic detail about particular components in the data path. Data path elements in millions instruction per second architecture. Here combinational elements, that means they operate on data values. Output depends on the current input and AND gates and ALU, no internal storage. When we are giving some memory element, then the sequential or state elements. Here we are using registers and memory. At least two inputs, data to be written to the data element, and clock determines when state element is written, and output, which is the value written in earlier clock. Building a data path, execute following instructions: arithmetic logical instruction, that means add, sub, and, or, and less than. Branch instruction, BEQ, jump instructions, load. Already we discussed about this in the first slide itself. Building a data path, R format, decoding and execution. Start with R format instructions will require, these are all the components: reading two registers, R-type instructions, addition. So example they given $S1 and $S2 are the input values. These values are taken from the registers only. $S1 and $S2 are the address for the registers where we are getting the data 1 and data 2, and then these two data are given to the ALU. ALU is performing the addition operation, and result will be stored in $T0 address. Here the program counter is doing the normal sequence of operation. That means first instruction is getting over, that program counter is incremented by 4 because each instruction is 4-byte instructions. Here a register file to read and write from and to registers, ALU to operate on the values read from the registers. We need to understand the internal design, register file and ALU. Building data path, ALU components, we have to see one by one. ALU component inputs on the ALU operation 4 bits and 2 operands, so 32 bits each are 32 bits. Output ALU result is 32 bits, that means 4 byte, and 0 is 1 bit. That is whenever we are doing some comparison, then both the values are equal, then 0 bit will be altered from 0 to 1. We want to be able to perform add, sub, add, and, or, nor, less than. Start with 1 bit ALU and build. Logic and or arithmetic include full adders. Building data path, there are 3 different components. One is instruction memory, program counter, adder. So for fetching the instruction, we required these 3 components. Need a memory unit to store instruction of a program. Simple implementation, only need address to access in the particular instruction. No write signals in this instruction memory. We are getting the instruction address from CPU or processing unit. Then with that address we are fetching the instruction from instruction memory with the help of program counter. Here program counter is a register that holds the address of current instruction, and then recall the each instruction is 32 bits wide. Adder to increment the PC by 4 to point to the address of next instruction. These 3 components are very essential for fetching the particular instruction from the instruction memory. Here register file internal operation is, here the collection of registers, any register can read or written by the specific register address. To read, supply a register number, no control signal is needed. To write, we need 4 inputs. Data to write, a register number, and write control signal and clock. Here in the instruction itself we are having a register address, so we are getting the address for register read register 1, read register 2 from the instruction itself. Then we can able to read the data from those instructions, those registers, and these are the inputs for the particular operation. And after performing the ALU operation, here to operate the values read from the register, that means these two read data 1, read data 2, then we can perform add, sub, and, or, like arithmetic and logical operations constructed from and or inverter multiplexers. Take 2